Alright guys, we're going to look at domain and range, and we've already looked at this one before, but we're going to talk about it more as exponentially. Domain is the input of a function. Algebraically, x values in ordered pairs, table or equation, graphically furthest left x value to furthest right x value. And that's important to remember, your furthest x and furthest y x value. Alright. Range is the output or y of a function algebraically, the y values from ordered pairs, table, and equations. Graphically, the lowest y value and the highest y value. That's also very important to remember. Alright. Steps from ordered pairs or an XY table. Domain, a list of x values as a set using brackets. Range, list of y values as a set using brackets. From the equation or in the context problem. Domain, identify the x represents an equation. Determine what the values of x make sense for this situation. Write using interval notation, inequality notation, or set notation. We'll look at those. Range, identify the what y represents in the equation. Determine what the values of y make sense for the situation. Write using interval notation or inequality notation or set notation. So we look first at your ordered pairs, and we're going to list our x values from least to greatest. So we got a -9, a -2, a 0, and a 1. Alright. Notice I only have 4 numbers in here. 1, 2, 3, 4, and I got 5 total, but I got 2 zeros. So therefore I only need to put 1 of them. My range is the same way, but notice I have 5 because I have 5 different range numbers. Alright, and then I'm putting that in interval notation. Alright. Okay, so we look at the next one. Same thing as what we had in ordered pairs. So we're gonna you just list your x values and your y values in descending order. Ascending order. Notice on this one they're already in that order for you, so it's not that hard to do. Notice we have 5 on both of them, so there's no numbers that repeat. Okay, the next one is a candle burns at a rate of 1 inch per hour. The original height of the candle is 12 inches. The function of the candle burning is f of x equals -x plus 12. So you start at 12, you go down. What are the domain and range? First of all, we figure out what our x represents, this number of hours. Alright, and our y represents the height of the candle. What makes sense? Well, we're going to either have 0 hours or 12 hours for our range. Notice this is not an ordered pair in this set notation here. And so we know that 0 to 12 is going to make sense because you're either going to have a 12-inch candle or no candle, and all the numbers in between. So however many hours you have for x here in our inequality notation, is what's going to make sense. Alright, and I also listed it out. Okay, the next one you can have mapping. We've already looked at mapping, where you list your x values and your y values without repeating. Domain and range, same thing with ordered pairs. Alright, right here the domain of f of x plus 2. What is the range? So all you do here is you're going to plug in your x values here. So you got y equals 0 plus 2, and that's what gave me the 2 here. Y equals 2 plus 2, that's what gave me the 4. And then y equals 4 plus 2, which gave me 6. So I can find my range by plugging it in. Alright, another one. Louisa is saving money to buy a new smartphone. It costs $430. She started with $150, and every month she saves $20. Her savings can be modeled by the function S of x, that could be f of x, equals 20x plus 150. Find the domain and range. So we know that x represents the number of months that she's saving, and y represents the money that she's made so far. Now, 0 to 14, the way for that, you start off with 0 months, which is where you have $150. Now, the 14 comes into play where we've done this before, where you take 430 and you solve your equation for x here. So subtract 150, subtract 150, you get 280 divided by 20, and you're going to get 14. Alright, and so that's where the second part of your domain comes in, because the highest you're going to go is the 14, because that's the money you're trying to save to. So it's going to take you 14 months, and then our table listed here shows us each month that we're saving. Now your range here is you start with $150, no matter if you save for any months, and your ultimate goal and what you're going to reach here is 430. Alright, so we look at graphically. Domain lists and order pairs in the following steps. If it's discrete, there's a list of ordered pairs following step 1 from least to greatest, or from left to right. If the graph is continuous, read the graph from left to right like you would read a sentence. Identify the furthest left x value on the graph and identify the furthest right x value on the graph. Write the domain using the interval notation. Alright. If the graph is discrete, list the ordered pairs, follow step 1. If the graph is continuous for the range, identify the lowest y value on the graph and identify the highest y value on the graph. Write the range using interval notation or inequality notation. Alright. And I think I said it wrong earlier. This would be set notation, and this is interval notation. Alright, so we look at the first one. Notice that we just have ordered pairs listed here, so it would be discrete. So we list out all our ordered pairs, and then we put our domain with all our x values. Notice that we look at our x values here, and we put our ranges, all our y values, from left to right. Alright, and from least to greatest there. Right here, this one is continuous. Notice how this one goes on forever right here. And right here, if you want to list it out and help you out, you can write negative infinity, positive infinity, positive infinity. So it'll help you figure out which infinity you're pointing at. So our domain is from left to right. Alright, so if you notice, our domain is our x value. And notice this is -4 right here going left on my x value where this point's located. So we go from -4, and it goes from left to right, and it keeps going on forever to our positive infinity. So it'll be -4 to positive infinity in interval notation. And that is not an ordered pair. That's just saying everything from -4 to your right is part of your domain. Alright, and then range, notice right here the y value is going up. It's going up. It starts at -1. Alright. Right here at on my y-axis. You notice it's at -1 here. Alright, so this point right here is at -1, and we go down to up. So if we go up here, we go from this point right here and we go up. That's positive infinity. So that's every point from -1 up is part of my range here. Alright. Looking at linear. Now linear is always going to be from infinities. If you want to go ahead and label your infinities out. you know, the line's going from left to right on the x value, from left to right. So we're going from negative infinity to positive infinity on this one. Now if the graph was negative, you'll see it will change on your range here. But we know on our range we're going from down to up. Notice it's going down to up, which is negative infinity to positive infinity. Alright. Over here we have another discrete one. And you can list out your ordered pairs, in which that's what I did before I did this. And my first ordered pair was -3, -1. My next ordered pair was -1, 2. My next ordered pair was 1, -1. My next ordered pair was 2, 4. And my last ordered pair was 3, -1. Alright, and then I just took those. I put my -3, I put my -1, I put my 1. Oh, I forgot a 2. Put my 2, and then I put my 3. Alright, I put my brackets around it. And then my other ordered pairs, I got -1, -1, and a -1. And I got a 2, and I got a 4. Alright, and I listed those down here. My next one is exponential graph. Alright, and this one is exponential decay, and we'll talk about that later. And if you notice, my y-intercept right here is at 1. We'll talk about that later too. But again, label your graph negative infinity, positive infinity, positive infinity. Now, we don't have to label this bottom one, because if you see this dotted line, it is an asymptote. And our asymptote here is going right through 0. So y equals 0 is our asymptote. So that's going to help us find our range in a minute. Now again, on our domain, we go from left to right. And that's from negative infinity, because the line's going, you see it going from left to right. Negative infinity to positive infinity. Now our range is a little different here. As you'll see on the range here, it says asymptote. This line right here will never cross 0 that's going down here, right here. So our range here from down to up is going from 0 on our y-axis to positive infinity. Alright. Again. On this graph, we look and we see it has a point at 0, 20. Alright, now if we saw the whole graph, we'd see an asymptote that would tell us a little bit more. We see a point 0, 20. So I got negative infinity. And the infinities, since that point's there, the infinities are not going to, I mean, you're going to see them because you still got it going to positive infinity and to positive infinity over here. So we know that's on 0 for x. So therefore it's going to be 0 for my x, and all the way it's going to go from 0 to infinity to the right. And for our y value, this is at 20. So 20, it's point at 20, and it's going up to infinity.